Hello, welcome to this lesson of our study of differential equations, particularly in ODE, ordinary differential equations, and then the first order. Okay, so this lesson will go through the solution to a homogeneous first order differential equation. Okay, so if you don't know anything about homogeneous first order differential equations, kindly go back to our last discussion we had before this. Okay, so we've already done a lesson on how to know that, or when to know that a differential equation, particularly the first order, is homogeneous. Okay, all right. So if you are not subscribed to my channel, kindly subscribe so that you support the channel and then we all grow together. Okay, all right. So let's start. So when you know that a differential equation is homogeneous, that's the first order, after going through all the things I did in the last discussion with you, then you use this transformation that you let some y, or use this substitution that let some y be equal to vx. And then from here, I will deduce all the things we will need here. And then when you pick an example, you just go through it straight away, okay? Now, with here, if I differentiate the whole of this equation implicitly with respect to x, I have dy dx. Okay, I have dy dx equals, dy dx is equal to, when I differentiate v, here just put it in mind that v is also a function of x. When I differentiate v with respect to x, I'll get dv dx, keeping x, so I have x dv dx. Then plus, when I differentiate x with respect to s, I'll just get v. Okay, and then here, making dy the subject, I have to multiply through by dx, and I have something like dy is equal to x, or let's say v plus, or let's say v dx plus x dv, right? So v dx plus x dv, or let me write it well. I don't know if you can see, but let me rewrite it again for you. Okay, so that you keep it dy dx, or dy is always equal to x dv plus v dx. So this is the transformation you use, these two transformations. You state that y is equal to this. Then after that, come and write that dy dx equals s dv plus v dx. And I've shown you how to get that dy, okay? I hope you get this. So let's pick an example and go through it. Now the first one is solve for y in the ODE. So here, in all my videos, I make sure that we make the function we are looking for the subject, okay? Alright, so to solve this, we've already explained this. This is homogeneous. Please kindly note that we said that if this is your m of xy, okay, m of xy, since this is in the differential form, you write this, and this is n of xy. Once this is homogeneous, okay, we say that to know that it's homogeneous, let me write this for you again, and then I'll not repeat it again, okay, because we've already done this in our last discussion. This should be equal to some lambda. This will give you this lambda squared, this, and then n of lambda x lambda y will also give you lambda squared n of x y. And since the degree here are the same, we say that this is homogeneous. Okay, I hope you remember. So if you don't actually remember, or if you don't know where the video is, just go through my playlist, and I have it in the first order OD. I have a playlist on that. Okay, so kindly go through that. Now with this, we said that the transformation you use, this is homogeneous. So what we just do is y is equal to vx. This is a substitution we do, and then we know that dy is equal to v dx plus x dv. So you keep these. Okay, so quickly let's go through that. We have s squared plus y, and y is what, vx. Okay, so you square that, then dx minus 3x, then y is vx, then dy is what, v dx plus x dv. Okay, and this is equal to 0. So I have to just expand everything. Okay, so I have s squared dx plus, when I square here, I'll get v squared s squared. Okay, then dx, then minus 3x squared v into v dx plus x dv equals 0. Okay, So what will happen is that if I try to divide through by s squared, okay, there's an s squared here, there's an s squared, there's an s squared here, so I just divide through by s squared, and I'll have dx plus v squared dx, okay, minus 3v into v, or let me multiply that 3v throughout. You let me write it for you, okay. I want to simplify everything for you, okay, so that you don't get confused. And this is equal to 0. So now I have that. Since I have dx plus v squared ds, I can factor dx out in this, okay, in this expression, and then we'll have something like, when I factor ds, I'll get 1 here. When I factor ds, I'll have what? V squared, okay. So let me add a page to it and we go. So I have 1 plus v squared, then dx, okay. Then we can let's write it that way, and then we have, when I expand this, I have minus 3v squared ds plus minus 3vx dv, okay. So I have minus 3xv, that's so, yes, 3sv, 3xv dv. Is it true? Let me see. 3xv, yes, we have something like this. This multiplying this will give me that, and then the other one will just be 3v minus 3v squared dx, right? This, so yes, 3v squared dx. So therefore this is equal to 0, and then when I add this and this, okay, there is a ds, so I just have to add them together, and I'll have, and then send this one to the other side of the equation, okay. So I'm doing them together. I have 1 plus v squared, okay, in one of the dx, then minus 3v squared, then all dx. So if I send the whole of this to the other side of the equation, I have minus, it's minus already, so I have 3x v dv, okay. So when I add these, I have 1 minus 2 v squared, okay, 2v squared dx, and we'll have something like is equal to 3x v dv, okay. So therefore I'm just going to separate this, okay. So first of all, let me try to divide this through by how do I call it, x, okay, so that this other part will be free from x, so that this x will take this s away, and then we'll have something like, let me write this here, this is the same, okay, then dx over x, this is the same, nothing has changed, okay. So I have 3v dv. Now I want to put the v's to the dv side, okay, so let's divide through by 1 minus 2v squared again, okay. This is still, if the x was here, this should have been all times, okay. I hope you understand what I'm trying to do, okay. This x is still a denominator, okay, then this 1 minus 2v squared, and then this will take this away, and then in fact we have dx over x, okay, dx over x is equal to let me see, it's equal to 3v, is it 3v? Yes, 3v dv over 1 minus, so 3v over 1 minus 2v squared, then dv, okay. So the other side is also the same as 1 over x, then dx, okay. So simply this is a separable differential equation where you have only the x and the dx at one side and the v and the dv at one side again, okay. So in effect, I can simply rewrite this as 3v over 1 minus 2v squared dv is equal to 1 over x dx, okay. So I want to keep the x at the right side almost all the time, so that when making y the subject, it becomes easier, okay. Now I have to just integrate through this, okay. 1 minus 2v squared, then dv equals 1 over x dx, then integral of that, okay. We know that integral of 1 over x is simply going to be very easy for us, 1 minus 2v squared dv, and this will give me ln of x plus a certain constant c, okay. So this is always true. Now let's go ahead and then differentiate this function. Okay, so here you have to use differentiate integrate that function, and then we have to use integration by substitution. Okay, so we have integral of 3v over 1 minus v squared, or 2v squared, sorry, 1 minus 2v squared, okay, dv. Now here you let your u be equal to 1 minus 2v squared, and then du dv will be equal to minus 4v. Okay, so making the v the subject, you have minus 4v dv is equal to du. I hope you can see what I'm doing. So dv is simply minus 1 over 4v du. Okay, I hope you get this. So let's go ahead and put it back. So I have integral 3v, then the denominator is our u. Okay, then our dv is at minus 1 over 4v du. So v can take v out. Then we have something like minus 3 over 4. I hope you understand this integration. Then du. So this should be minus 3 over 4. Then ln of u. Okay. So that is the integral form of the right side of the equation. Okay. This side. So I quickly come and put it here. Okay. So I have let's rewrite this in terms of our v over 4. Then our v is what? Ln of 1 minus 2v squared. Okay, so you should keep this. All right. So therefore we know that is the integral form, and so this implies that the integral that gave us this ln of 1 minus 2v squared should be equal to the ln of x plus c, because at the end that was what we were doing. Okay, this should be equal to that, and then this gave us that integral minus 3 over 4, then that. Okay, so with this we know that our y, the question gave us a function of y was a function of x, not v. Okay, but remember that y is equal to vx. That is the substitution we did, meaning that our v will be equal to what? Y over x. So I come and put it here, and I have minus 3 over 4 ln of 1 minus 2 into y over x, then square it. Okay, and this is equal to ln of x plus c. Okay, so what will happen is that I have to just multiply through by negative 4, and then I'll have something like 3 ln of 1 minus 2y over s squared, all squared. Okay, is equal to minus 4 ln x, then plus the c times minus 4, and that is still a constant. Okay, so let me call this capital C, or you can call it A if you want. Okay, then I have to divide through by 3 again, so I have ln of 1 minus 2y squared, let me expand that, over s squared, then equals minus 4 over 3 ln of x plus a capital A, let me call that. Okay, so after dividing through by 3, this is what we have. They are all constants. Okay, so to take the anti-logarithm of both sides, e has to come and raise all these powers. Okay, so I have 1 minus 2y squared over s squared. Okay, and this is equal to e to the power, let me write this first, 4 over 3, then ln of x, then plus a. Okay, then this will give me 1 minus 2y squared. I'm trying to make y the subject. Okay, we are done with solving it. Then e to the ln of x to the power minus 4 over 3. Okay, and plus a. So the plus a will just give us 1 minus 2y squared over s squared is equal to e to the ln of x minus 4 over 3, then times e to the a, because that is a plus. A means that, okay, they are of the same power. So when you use indices, you get back this one. Okay, Then e to the power a is still a constant, let's say b. And then let me write something here for you. E to the power ln of something, let's say ln b, is the same as e to the power logarithm of b. I'm going to break everything for you, okay? Then since this base and this base are the same, this whole thing is equal to the b, I mean this one. So this implies that the e to the ln of x to the negative 4 over 3, okay, is the same as x to the negative 4 over 3 if you consider that as our b, okay? So this whole thing will tell us that you have 1 minus 2y squared over s squared should be equal to a constant b times x to the negative 4 over 3. Meaning that if I multiply through by s squared, I have s squared minus 2y squared being equal to b, then s squared times this. And then this will be s to the power minus 4 over 3 times s squared, and that will be plus 2 because s squared times that, we have x and x, then you add the powers, okay? Then we'll have minus 2y squared is equal to b, then x to the power 2 over 3, okay? Then minus s squared again. So we have 2y squared being equal to s squared. I divide through by negative 2. Let me do that quickly. Negative 2, and then I have y squared rather, okay? I'm sorry. I have y squared rather. Okay? Because this, okay, s squared minus bx to the power 2 over 3 all over 2. Okay, this means that my y is equal to the square root of s squared minus bx to the power 2 over 3 all over 2. And this is my solution, okay? Y of s is given by this. So given initial conditions, I can find a particular solution with doing away or trying to find a particular value for the b as the constant, okay? So now let's go through the second one. The second and the third questions are very easy, okay? So find the solution y of x of the ODE this. And then in our last discussion, we made mention that if we have an ODE that has the y prime or the y ds being a dependent on the ratio y over x or x over y, then this is homogeneous. Okay, this is homogeneous because of this ratio we have inside here. So if you can express y prime as a function of or as a dependent on the ratio y over x, then this is homogeneous. And then once it's homogeneous, we let our y be equal to what? V dx, and then our dy will simply be equal to, like we said, dy will be equal to v dx, okay, plus x dv, okay? So quickly, let's pick our differential equation. This is it. Dy over ds equals y over x, then like that, okay? So you have dy dx equals y over x minus y over x all squared. We know dy is what? V dx plus x dv, and our x is still ds, then y is what? Xv, then over x minus y, which is xv over x, then squared, okay? So divide this whole term by ds, and it means that v ds over ds, and that will give me v plus x dv over dx, okay? And this should be equal to s cancelling x, I have v minus s, will take this out, then square it, I have v squared, okay? So I will have to take my v squared out to the other side, this v to the other side of the equation, okay? And I'll have x dv over dx is equal to v minus v squared minus v, and so this v will take this v away. So in effect, we have only minus v squared at the other side of the equation, okay? And this implies that we have x dv multiplying through by ds minus v squared dx, okay? So this shows that if I divide through by x, I have dv is equal to minus v squared dx over x. Okay, now let's try to divide through by minus v squared, and we'll have minus dv over v squared is equal to dx over x. I hope you get this. So this is very simple and it's separable. Okay, we've been able to separate this into this is equal to 1 over x dx. Then integrate both sides. Okay, so I integrate minus 1 over v squared. So minus 1 over v squared is the same as minus v to the negative 2, okay, from indices dv, and this is equal to integral of 1 over x dx. Now the reason why you didn't write this as the 1 over x as minus e to the negative 1 is that when you integrate that you get problem, and then we know how to integrate 1 over x. Okay, but here is 1 over v squared, not just 1 over v. Okay, so integrating this, we'll have minus into the integral of v to the negative 2 is this plus 1 over negative 2 plus 1. Okay, I want to go through this with you so that I don't get confused. Okay, plus a constant c. So in effect we have v to the negative 1 over negative of that over negative 1, then this will take this one. Okay, so in effect we have v to the negative 1, and v to the power negative 1 is the same as 1 over v. Okay, so I have 1 over v is equal to ln of x plus c. Okay, but y is equal to let me write it here. Y is equal to vx, and then v is equal to what? Y over x. But 1 over v is a reciprocal, then that will be x over y. Okay, so this means that I have x over y here being equal to ln x plus c. So I want to make y the subject, so I have to just reciprocate everything. So now I reciprocate the left side of the equation, I have y over x rather, and this is equal to the reciprocal of the right side, and that is 1 over ln of x plus c. Okay, plus c. So this simply means that my y is equal to multiplying through by x. I have x over ln of x plus c. Okay, this is very simple like that, so that if you have initial condition you can find your y. I hope this is cool, right? Now let's quickly walk through the last one, and I'm pretty sure you'll be able to solve every first order ODE, which is homogeneous. Okay, so I have this one. Let me just divide through by xy so that we can get a ratio, something like x over y or y over x. Okay, so I have this and plus y squared over xy. Okay, so realize that this will take one of the x, so here will go, and then the square will go, and this one to the y will go, and then the square will go, because they will be taking one of them. Okay, so I have y here and I have x here. So this one, since this is dependent on the ratio, this and this ratio, okay, I mean this is homogeneous, and that we just say that y is equal to vx, and you know that dy is also equal to, dy is always giving us v dx plus x dv. Okay, so put everything here, and I have v dx plus x dv over dx, and this is equal to y is equal to v over x, vx. It means that y over x is equal to v, and that x over y is equal to 1 over v. Okay, I hope you get this. I hope you understand. So x over y is what? 1 over v, and then y over x is what? V. This is very cool, right? So we quickly cancel some terms. Okay, let me rewrite it here for you. So I have, when I divide through by that, I have v dx over dx plus x dv over dx. This is the left side of the equation. This is equal to 1 over v plus v, and that this will take this away. Okay, so you have v plus x dv over dx, and this is equal to 1 over v plus v. So x dv over dx is equal to 1 over v plus v minus v. Okay, and that this minus v will go, so I have that. So I have x dv being equal to 1 over v dx. So if I multiply through by v, I had vx dv is equal to dx. Let me divide through by x, and I'll have v dv being equal to 1 over x dx. Okay, so in effect we have v dv being equal to 1 over x dx. So as I have to just integrate each side. Okay, we've been able to separate it. So integral of v dv will be equal to integral of 1 over x dx. Integral of v is what? Dv with respect to v is what? 1 over 2 v squared. Okay, then I have is equal to ln of x plus c. So v squared is equal to 2 ln of x plus, let's say, a, because 2 times c will give me another constant. And v, since v is what, how do I call it? V is the same as y is equal to vx. Okay, so v is equal to y over x. So I have to just, wherever I see v squared, I put y over x there. I have y over x, or y squared over s squared. When I square that, that's what I will get. Then 2 ln of x plus a. Okay, so adding pages, I have y squared multiplying through by s squared. I have 2s squared ln of x plus okay, let me rewrite it in a different way because I want to get something cool. Okay, I have s squared, or let's say this, we have y over x as my v, then square is equal to 2 ln of x plus c. Okay, we want to get something very easy. Okay, the finding square root of both, so I have y over x is equal to the square root of 2 ln of x plus c, and then I have y equals x into the square root of ln of x, 2 ln of x plus c. So this is very, very simple, right? Very, very easy. And I think I turned this to a, right? Yes, I did it as a, so you can change this to a as well. Okay, this is very cool. This is how you solve homogeneous first order differential equation. Okay, so thank you, and also try this. Okay, and you let me know if you're able to solve this. Okay, so your try question is this. Please just comment in the comment section. Okay, dy dx is equal to 4x plus y. All of these we simplify them to show how or why they are homogeneous in our first lesson on homogeneity. Okay, solve this. Okay, and then the answer, or the expected answer, is y of x is equal to x over a minus ln x minus 2x. So you should take note of this. This is the solution you will get if you're able to go through it. So just go through it and give me a comment in the comment section if you're able to do it, and tell me if you are not able to do it. Okay, so that I will give you a hint on that. Okay, thank you, and see you next time. Don't forget to subscribe to my channel if you have not subscribed. All right.